Okay, so what we're going to be looking at in this is we're still going to be in Lesson 6-1, and we're answering questions 10, 11, and 14. Okay, so question number 10 is asking, if a function is even, which transformations will always maintain the symmetry of the graph, and explain why. All right, so I want you to think about it for a second and pause the video so you can write your answers down. Which transformations will maintain that even symmetry over the y-axis? All right, so pause the video and write down which ones you think are true. All right, so let's see what you came up with. All right, so in order to maintain your even symmetry, what you have to do is you have to keep the middle points of symmetry on the y-axis. Okay, so I'm thinking absolute value quadratic quartic. I want that vertex to stay on the y-axis. So anything that keeps that vertex on the y-axis or doesn't move it off is going to maintain that symmetry. All right, so we have several things. If we are stretching and compressing, we're going to maintain that symmetry because it's staying on the y-axis. So we can have a vertical stretch or compression. And all we're doing is we're making it taller or shorter. We're not moving the vertex, all right? So that's what we want to do. We don't want to move those vertexes, all right? We can also do the same thing horizontally. We can make it wider or skinnier horizontally, and we're still not going to move the vertex off the axis. So both of those will maintain the even symmetry. Okay. We can also translate it. If we translate it horizontally, the vertex moves off the y-axis. But if we only translate it vertically, then it stays, that vertex stays on the y-axis. All right, so if all you have is a vertical translation in terms of movement, you're still going to maintain even symmetry. And then both of our reflections are going to not move the vertex, and so we can reflect over the x or y-axis. All right, so lots of transformations will maintain even symmetry. The only one that really causes it to no longer be even is that horizontal transformation. Okay, similar question, if we have an odd function, which transformations will always maintain the symmetry of the graph, and explain why? So I want you to do the same thing we just did for 10. Pause the video and write down which ones you think will work for the odd or origin symmetry. Okay, what we want to do on this one is we want to keep that point of symmetry at the origin. Okay, so if you think of a cubic, that's that inflection point, okay? And so whichever ones keep that point of symmetry at the origin are going to be the ones that work. All right, so again, if we're vertically stretching or compression, we're not moving that point of symmetry, so those will work. All right, a horizontal stretch and compression are the same thing. We're not moving that point of symmetry, so if you have just a horizontal stretch or a compression, those will be fine. However, if we have any kind of transformation, okay, whether it's vertical or horizontal, it will move that point away from the origin. So neither type of transformation works. Sorry, not transformation, but translation. Neither translation will maintain the symmetry. But again, if we're reflecting, as long as we haven't translated anything, we're going to be fine. So you can have a reflection over the x or the y-axis. All right, so so a lot of ways that we can maintain odd symmetry. The one way, or the two ways that don't, is if you're doing a type of translation. All right, so now what I'd like you to do is I want you to answer question number 14, and pause the video and play the video when you're ready. Okay, so let's see how you did. So let's look at these four graphs. 2 over x is a rational. Remember, originally it was odd. What we're doing here is multiplying by 2, which is going to be a vertical stretch. And so that is an okay one, and it's going to maintain our odd symmetry. If we look at b, it's a logarithmic. There's really not much we can do to make a logarithmic anything else other than neither. All right, so even if we multiply that by 2, it's going to stay neither. Okay, on question C, we're taking a cubic, which is an odd function, and we're multiplying it by 0.25, which is going to be a vertical compression, and so vertical compressions will maintain your odd symmetry. And then on D, we have an absolute value graph that we've reflected, which is okay, but then we also did a vertical translation up, which is also okay to maintain your even symmetry. So both of those transformations, the negative and the +2, maintain your even symmetry. All right, so there you go. Make sure that you've, the only questions we didn't answer in this lesson were 12 and 13. You don't have to worry about those.